Hi guys. So this first question is a very important topic in mathematics. In fact, we'll be revisiting it many times throughout the year. What is an inverse? So inverses are really an important idea. Basically, what an inverse is think of it as something that undoes something else. So like if I um, give you $5 and then take $5 away, that's inverse. One thing undid what I did before. All right, so an inverse is basically like the undo button. All right, so if I do something over here, if that's one operation, the inverse would be undoing that. I don't know why I didn't erase that. All right, so think of undoing when all right, so I could delete this. The inverse of deleting would be adding it in there. So, all right, so think of inverses as like the undo button. All right, they undo whatever we did under a certain operation. So it depends on what operation we're talking about here. So for addition, what is an additive inverse? All right, it's whatever unadds the number you added before. All right, so it's the negative and technically it's the opposite sign. Spelling counts, I guess. It's the opposite signed number. So if the additive inverse of 3 would be -3, right? If I add 3, then add a -3, I've really done nothing in the end. All right, find the additive inverse of -1/2. Well, that would be +1/2, right? So the way that would look is x minus 1/2 plus 1/2 just equals x. They undo each other, right? So what's an identity? The identity is what you get when you compose two inverses. Now, I said the word compose because it depends on whether we're talking about addition, multiplication, division, or whatever. So under addition, if we add two inverses, what do we get? Well, -1/2 plus 1/2 equals 0. All right, so the additive identity is 0. Basically, it's what if I take anything, x stands for anything, and I add what to it, what will give me x back? It has to be the identity. So for addition, what does this have to be? That has to be 0. So 0 is the additive identity. All right, we have a similar idea with multiplication. What is a multiplicative inverse? All right, so for multiplying, if we want to undo multiplication by multiplying by something else, really what we have to do is multiply by the reciprocal. Reciprocal is the flipped version of the number. So if we have an x times 3, right, the multiplicative inverse of 3, how do we unmultiply by 3? Well, we'd multiply by 1/3, right? Because x times 1 times 3 times 1/3, these reduce and just gives us what we started with back. So what undoes multiplying? What's the undo for multiplying by 3? Multiplying by 1/3. What's the multiplicative inverse of -1/2? It's going to be -2. All right, so they keep the same signs in multiplication for inverses, right? So what is the multiplicative identity? Well, it's what you get when you multiply two inverses. So what did we get when we did 3 times 1/3? That equals what? Equals 1. What do you get when you do -1/2 times -2? Right, if we want to use our fraction rules, in case you forget, 2/1. These reduce, a negative times a negative is a +1. So the multiplicative identity is 1. And that's because we want to think of if x is anything, right, or even anything, some number, some variable, some whatever, times what will give us the same thing. What do we multiply that doesn't change it? And that's going to be our identity. And that has to be a 1. All right, so 1 is the multiplicative identity. And then what is the multiplicative property of 0? That just says that anything times 0 is 0. So anything times 0 equals 0, or 0 times anything equals 0. And that's even like 0 times something like that. Even though there's in parentheses, you have to do parentheses first, 0 times this is 0. That's the multiplicative property of 0. So let's see it in action. Oh, wait, a couple more properties. The commutative property. Commute, you ever heard of like your daily commute when you travel someplace? So if you can move the numbers and it still works, that's the commutative property. So here's what I mean. That strictly says that, well, look at this. Is this true? Is 2 plus 3 equal 3 plus 2? Well, sure it is. All right, so that means that the commutative property works for addition. All right, 2 times 3 equals 3 times 2. So that's the commutative property for multiplication. So multiplication works. Now, if we do it for subtraction, that doesn't work. 2 minus 3, 3 minus 2, those are not equal because that's a negative 1, and this is a positive 1. All right, same thing for division. Division does not work. 2 divided by 3 does not equal 3 divided by 2. If you plug them into your calculator, you get 0.6 repeating, and this gives you 1.5. Those are not the same. So the commutative property is when you switch the variables or move them around, and you still get the same result. The associative property is when you group different terms together, does it still work under a given operation? So for like a times x plus y, does that equal, no, that's incorrect, a plus x plus y, my bad, does that equal a plus x plus y? So if it's all additions, does that work? Well, let's try with a couple numbers just to prove to you that it really does work. 2 plus 5 plus 3. Is that the same as 2 plus 5 plus 3? And yes, it is. 5 plus 3 is 8. 2 plus 8 is 10. 2 plus 5 is 7. 7 plus 3 is 10. So that works. That's the associative property. Notice that we associated the second two terms together or the first two terms together. When it's all addition, it works. The associative property also works for multiplication. I don't want to take your time to do another example. I just want to show a few of these, and then you'll be ready to do your short little U-tries down here. So 1/4 times x equals 1. All right, so that would be, this has to be the multiplicative inverse, right? That would have to be a 4, but I'm not asking you what the number has to be. I'm asking you what property is it. So it's the multiplicative inverse, all right? Because you multiply inverses and you get the identity. So what is this? We have 3 plus 8 and x plus 3, and these have to be equal. So we know this has to be an 8. But if 3 plus 8 equals 8 plus 3, this is the commutative property. That's when the numbers can travel or change places and still give you the same result. So what times 4 equals 4? Well, since it's multiplying, we have the multiplicative identity, right? You multiply an identity or do an identity to a number, you get that number back. So it's multiplicative identity. Getting a little messy, I'll switch my colors here. What do you add to something to get that back? Well, that would have to be the additive identity. Right? And you know that has to be 0. The other way you could say it is the identity for addition. So if you multiply these two together and you get what? You get the identity. If you thought this was the property of inverses, that would work too, because when you multiply inverses, you get the identity. So they're very related. Here, this would be the you know this has to be an 8. So what property use? The property is additive identity, or identity for addition. So you just have a few quick problems, which based on this lesson, you should be able to do very easily. And I'll see you tomorrow.